Hi, this is Mark, and I'm back with the shorts on storing AES keys in key stores. Now, the last time we created a key store and an AES key all sort of in one function, and I kind of wanted to break that up a little bit before I kind of wrap things up with the different kind of key stores and maybe some weaknesses with the key stores themselves. So before we'd done this and we tried to see if there was a key store. If there wasn't, we created a key store, and then if there was a key in it, wasn't a key in it, then we created it all in one shot here. We don't really want to do that in general, so I'm going to replace sort of this functionality with what I've kind of coded up earlier, and I'll just kind of walk through the code that I've created earlier to do this. And so what I kind of followed was the builder paradigm. Now the key store manager class that we had before now has a builder private class for it. The builder private class is going to allow us to do things like get the builder, uh, pass in what the password is going to be for the key store, give it the key store file name, and then tell it what type of a key store we want to use. Now, we've been using PKCS 12 key stores in the past in these videos, but there are other types, and we'll talk a little bit about them and some of the weaknesses. And then I'll refer you to a place to go look at the weaknesses on some of the key stores. And then, of course, we have the build function, which just sets the variables within the current key store manager that we're trying to create with the builder, and then just return that key store manager as a part of the build function. We'll go over the key store stuff later. So you'll see now we don't really need this key store create with AES key anymore, as we're going to do this all through a builder and have accessor method. So I'm just going to go ahead and get rid of it now. And so now we've got it out of our class. And then if we look back over the builder with the password, the key store file name, and the type now, so now we have an object that we can use. One of the things that we're going to want to actually probably have access to is the key store itself. So we add an accessor method here to either create a key store if it's not there, or get the key store that's there. So this method just says, okay, return the actual key store that I'm working with, and that's the underlying key store that we're trying to manage here. There's another method here called get AES key. We're going to do a couple of different things here. In the last method, we used the same password for both the key store and for the key entries themselves. There's a number of reasons why that isn't a good idea, especially since we have the flexibility of being able to put different key stores entries with different key store passwords. So now that we have the key store entries here, we can actually get them. Now this method, it actually just is a sort of wrapper, a shortcut for getting a key store without creating one. But then of course we can add a Boolean to our get AES key that will tell us yes or no, do we actually want to create a new alias with this method call. So with this method call, we're going to just look into the store and make sure the store is there. We're going to look for an alias. If it's not found, we're going to create a new key for it. And this code right here is just very similar to the last code we did in the last video. And we just use our AES key class that we created. We look for a new key store file. We look for the entry. We put the entry in there because obviously there was no key store here, so obviously you're going to have an entry in it. And then we create the entry and close the store, and sort of throw any alias not found exceptions if we want to do that. Now, otherwise, we have a key store, and we're going to look for the entry that we have. If not, we're going to create the entry. And of course, this is predicated on whether or not we've instructed the method to actually create a new entry for it. And then we're just going to, of course, get the secret key and return the key so that we can call this method at any point and say, okay, I'm just going to get the key at that alias. If it's not there, I'm going to create it. Of course, could have some strange side effects in your software where if you thought you had that key before and it encrypted with something and it actually wasn't there, then you're obviously going to fail the encryption. But hopefully, just doing this subtle way of sort of lazy initializations will not cause you issues in your software. If it does, then don't use the lazy initialization and have this method just either return that it's not there in the case that it's not there, and then create another one that actually creates it more autonomously. So let's look at what that might look in action. So I'm going to switch back over to my unit tests where I have this create store. You'll see I've got some commented out code. We're going to talk about that here in a minute, but at this point now you can see that we can actually use the builder class that we created. We said, okay, here, create a new key store with the builder with type some long password, or with some long password, with type pkcs12, what we did before, with the KS file name, and we created the file name here in our home directory, data key store. And then we called the build method, which actually returned the key store manager itself. Now with this key store manager, we can go look at those two methods that I created earlier. And in this case, I know there's no keys in there, so I'm not just going to do a lazy one. I'm going to set it as I want to create these keys. And so I'm going to call get AES key, some long password, 2, true. And you'll see here now that I have set a different password for the key entry, and I created 2 entries here, different one for the third one, and then of course the long password for the key store itself. Now, I guess to get back to, well, why would I want to do this? So kind of the default behavior that is done with key stores these days is that they have the same password as they do for the key store as they do for each of the entries. And it can lead you to some vulnerabilities, especially since the password for the key store is just used for integrity check, and it's not actually encryption. So there's a SHA-1 hash of this password in the key store that can lead you to some vulnerabilities. Now there's a good presentation out there called Nail in the Coffin of the Key Store. You can search that on the web. That'll show you how breaking these key stores is a little easier than you might expect. And one of the things that they recommended there for doing that is, of course, separate your key store passwords for the entire key store versus the one for the entries themselves. The entries themselves will have a little bit better algorithm behind it. It's not the greatest, but it's a little bit better. So recommendations for here is separating these passwords from the entry files themselves. Okay, you also see I have a bit of commented code in here. One of them is for a bouncy castle provider. Now the reason we've used this provider is because they offer more types of key stores than standard Java knows. So for instance, these are the different types, and I'll leave this code in the repo so that you can kind of play around with them and choose which one you want. Recommendations are the BCFSK seems to be the strongest one to use, but again, that's a third-party one, so you're not going to be using standard Java, and so you could run into problems with anyone who's expecting PKCS12 or a JKS. They also state that the JKS is the weakest one, and that's the one you want to kind of stay away from. So just to kind of wrap it up, this was the things that we wanted to do to manage AES keys inside our key store. And like I said earlier, go look at the vulnerabilities you have with key stores, Nail in the Coffin. And that one specifically talks about the JKS ones and gives us reasons why we want to make sure that we use one of these other types if you want to have a more secure solution. Okay, so that's all for today. Thank you for your time.